Hello everyone, welcome to our teacher. I'm a physics teacher. Today we are going to deal about the introduction part or the main points or main topics of our lesson, human eye and colorful world. Okay. Basically in this lesson we will deal about the human eye and its working process and things related to human eye. Okay. Human eye works on the principle of sensation of vision. Sensation of vision. It means human eye only is able to detect the reflected rays from an object. Okay. So whenever only the reflected rays from an object is clearly fall on the retina of the human eye, then only we can say we can identify an object. Okay. The next one we will deal about the topic like LDDV. It is known as least distance of distinct vision. So it is an important topic. So it is a minimum distance at which a human eye, a healthy human eye, can clearly see an object, and the value is given as 25 centimeters. So we will deal about this topic. It is represented by the symbol capital D. Okay, and then the next one we will deal about the topic known as angle of vision. So what is meant by angle of vision means it is simply the angle of vision is nothing but the angle up to which a human eye can clearly see an object. In this topic we will deal about how does a human eye is able to see. So if you take this as horizontal line, and if you take this is the angle of vision for the object, this is the object like it is like A dash, B dash, and this angle keep on going, and this distance of a stick, let us suppose it is stick AB. So a person is able to see the stick AB only, even though A dash B dash is having same length as that of AB, we cannot see. Why? Because it is much near to the human eye as comparing to stick AB. So this is known as angle of vision. So we'll come across the angle of vision for a human eye is approximately 60 degrees. Okay, and this concept in the concept of least distance of distinct vision, the value of this 25 value is not a fixed one. It keep on changing. It value changes from person to person, from person to person, and with age. And with age also, and with age also, the value of least distance of distant vision also changes. Here also, the angle of vision will also changes from person to person. Not in more of the cases, but the average value could be taken as 60 degrees. Okay. So students, in the next topic we will deal about a human eye. This is the human eye, and the parts of human eye, if you see, first of all we have cornea. Cornea is the outermost part of the eye. Later we had what it is, aqueous humor. Aqueous humor is a liquid which is filled in between the lens and the cornea. Okay, and we had a muscular diaphragm is known as iris. Okay, and muscles are there here known as ciliary muscle. These ciliary muscles will control the lens, and this lens is hard at middle part and thin at outer parts. And here we had an optic nerve. Behind it, a screen-like structure is there known as retina. Okay, so these are the parts of our eye, human eye. This is biconvex lens actually. What are the purpose and how does the human eye works? Let us see in a short way, right? The lens is controlled by, if you see here, pupil is actually black portion of our human eye. Pupil is controlled by, if you see, pupil will be controlled by iris, diaphragm, or iris will controls pupil. Okay, so this one is the first part. And if you see the next one, lens. Lens is controlled by ciliary muscles. So lens is controlled by ciliary muscles. Okay, how does iris will control pupil means, if a more intensity light is coming or trying to enter your eye, then the iris will make the pupil size small, so only some part of light will be enter into eye. Similarly, if you are seeing a far object, then ciliary muscles will be relaxed. This will be relaxed. So it do not show any kind of stress on the lens. The main purpose of ciliary muscles is to control the lens, such that here if you see the distance between the screen and the lens is 2.5 centimeters. And it is a fixed value actually. We cannot change. That means image distance is constant. Okay. So ciliary muscles will control lens. What they control means actually they will control focal length. They will control focal length. So as we know this formula, lens formula, 1 by f is equal to 1 by v minus 1 by u. Here the two things which are, the thing which is variable is u will changes. U means object distance. F also changes here. F also changes here. But v is fixed. V is only a fixed value. Fixed value like 2.5 centimeters. It do not changes. Okay. So that is about human eye. The next we will deal about the remaining parts. So if you take any human eye like this, a person, a healthy person, human eye is like this. So let us take this one as backside of eye as retina. What kind of lens? Biconvex lens actually. So a person, healthy person can see any object which is far away from him. So these are the light rays which are coming from a far object, and they're trying to converge, not trying actually, they have converged on the screen. Retina is the screen here. Retina is the screen. So image formed here. It's okay, right? And this concept or this process of appearing of image will be occurred or happen till then, which point? Least distance of distinct vision. So if I take this one as the least distance of distinct vision, it is the final point. If you go beyond this, you can't get a clear image. So this is the final point. Up to which, if you take biconvex lens, up to which you are able to see, a healthy person can see a clear formation of image. So this is a healthy eye. Next we will deal about defects in eye. Eye defects. Eye defects mainly are of three types in this lesson. We will deal about first one, myopia. Myopia. Myopia is nothing but the defect in eye in which a person cannot see near object. Far object. Okay. So he can see only a near object. So this one also called by the name of nearsightedness. Okay. A person only sees a near object but cannot see a far object as that of healthy person. This condition is not possible for myopia. So if you draw the ray diagrams for the person who is suffering from the defect of myopia, it is like this. Take a point like, let me take point M as the myopia point, and L is the least distance of distant vision. Okay, what I have discussed, this is the final point up to which a person can see an object. So this one is the defective lens. So a person can see only the object which is at in between. This is the maximum point. Understanding? In between M to L, the object can be at any place. Okay, but if the object just jumps away or move away from point M, the person cannot see object clearly. Why? Because let us see. So if this is M, the object is here. So the light rays or the formation of image, actually this is the object, the formation of image will be happen somewhat in front of retina. So this one is the defect. I hope it's clear. So the remedy or the correction or remedy for this type of persons who is suffering from myopia is by taking biconvex lens. Biconcave actually, not biconvex lens. Taking biconcave lens. So this is the defective. And here we have biconcave lens. Okay. So by taking biconcave lens, now a person can see an object which is beyond myopia point. So hence it is now possible, it is now possible to see an object here. So biconcave lens is the remedy here. Okay, let us see the next defect in eye is known as hypermetropia. This defect is also known as farsightedness. It means the person who is suffering from hypermetropia is able to see far objects, but this person is not able to see near objects. If you try to draw the ray diagrams for this defective eye, the diagrams could be like this. So this one is defective lens. The person has, already we know this is least distance of distant vision, and this point let us take it as H. H means hypermetropia point or far point, a near point actually. So a person is able to see any object which is beyond this point only. Okay, if I take an object here, happily the person can see the object. There is no kind of problem. The person can see the object exactly. Clear? So only the person can see objects which are beyond H. I hope the point is clear. So if the person or the object is at H or in between H and L, no clear image will be formed on the retina. So if you take H and L, and if you take any point in between these two by convex lens, if I take an object here, the image will be formed beyond retina. Beyond it. In previous condition, the image formed before the retina, but here the image is formed beyond the retina. So this is the defect in eye. To overcome this, we will use another biconvex lens as a remedy. So the correction is to take biconvex lens. So in front of this, we will take another biconvex lens. This one is H, this one is L. So let us take a point object in between these two. So our main goal is to detect an object here. Okay. So if you draw a line from the object, it falls here. Refraction like this. Refraction like this. So it seems like the light rays are coming from other way. That means here the image formed acting as object for the lens. So hence the problem can be overcome. The next one we will deal about presbyopia. And this defect in lens is because of aging. For aged people, this defect will occur. Okay. In some people, the defect of presbyopia is because of both hypermetropia, myopia, and hypermetropia. So for such a people, we will use biconvex lens, bifocal lens actually. So bifocal lens is a combination of both convex and concave lens. Okay. Then later we will deal about the concept known as power of lens. So what is meant by power of lens? Simple. It is actually the degree of convergence or divergence. It is degree of convergence or divergence of lens simply. So in this topic we will deal about basically by taking lens, by convex lens. This is known as optic center or principal axis. Actually this is principal axis. We will send light ray and it is deviating like this, known as focal length. This is focal point and this length is known as focal length. And we will deal about power is nothing but equal to inverse of focal length. And the units of power is nothing but diopters. Diopter is represented by D. So that is about power of lens. Power of lens could be positive or negative. It depends upon the type of the lens. Okay. The next we will deal about the topic known as dispersion. Dispersion of light using prism. This concept is done using prism. Dispersion of light is nothing but the phenomenon in which white light is being spread out or will be deviated or will be dispersed in 7 colors known as FGR: violet, indigo, blue, green, yellow, orange, and red. Okay. And among this, if you see, we will deal mainly about violet and red. Those two are extreme colors. Among these two, red has least deviation, and violet violet color is having most deviation. Okay, by covering these topics also, we will come across the concept of refractive index of prism, finding refractive index of prism, and we'll come across refractive index is nothing but n equal to sine a plus dm by 2 divided by sine a by 2. This is nothing but the diagram which is given for the concept. Simply I am drawing a schematic diagram. So this is the incident ray, this one is normal, and here it been refracted minimum deviation, and here also normal. This is the emergent ray, right? So this is known as angle of collision, and n is nothing but the refractive index, dm is minimum deviation, a is the angle of collision. Okay, right. The next topic we will deal about formation of rainbow. Rainbow formation is very simple topic. In this topic we will discuss about the necessary conditions, on which conditions are the favorable conditions in which the formation of rainbow will be happen. So we will deal about the condition first of all. And the diagram for the formation of rainbow is, this is a water droplet which is subjected to a beam of sunlights. Okay, so whenever the sunlight is white in color, whenever the sunlight is entering into the droplet, this is droplet, water drop, what happens means here dispersion will be occurred, right? So dispersion I already told you, we will discuss not all the colors. It's not possible to discuss all the kind of colors in one set of diagram, so we will deal about extreme colors. Extreme colors are nothing but violet and red. Among these two, which one is the most deviating one? Violet. And which is the least deviating one? Red, right? So I will take one diagram from one light ray. Let us take here dispersion of two light rays. First one is this one, later this one. Okay, later here what happens, here dispersion occurs, and here the concept of total internal reflection will be happen, and this is the two light rays. So this one is red and violet, here also it is red and violet. So if you see, these are two angles, this is 40 degrees given in your textbook, as well as this is 42 degrees. So the violet is the most deviating color, and here we had our human eye, we are able to see one of the colors. So the vision of or the color which is appearing to you depends on the angle of vision. Okay, and it is hard to see the red color. Why? Because it need a more elevation angle as comparing to violet. So mainly this topic of formation of rainbow is a combination of two concepts: dispersion or dispersion, and next one, total internal reflection. And actually this formation of rainbow is nothing but a conical shape. If you see, it is a cone, but on the surface of earth we are only able to see half of the rainbow. So at a higher altitudes, if you go for hilly places, you can see a complete rainbow as a cone. So this is the topic about rainbow. And in the next topic we will deal about scattering of light. So this topic of scattering of light is one of the reasons why the sky is in blue in color and the deep seas are also in blue in color. So in this concept of scattering, very simple, we will take an atom around which an electron is revolving here. So when we subject some amount of light rays onto the atom will absorb, or the electron will take this light energy light energy and excited to higher states, and they will de-excite after some time to the lower state. In this process, they will redistribute the light energy in all possible directions. And this topic of, or this concept of redistribution of light is in all directions is known as scattering of light. And another topic in this one is known as angle of scattering. What is angle of scattering? It's simply very easy. Angle of scattering is the angle between incident ray and this scattering light, right? For suppose if you take this one, this is known as angle of scattering. Okay, and this concept of angle of scattering or the concept of scattering of light will be happen in atmosphere. And this leads to blue color. We had nitrogen and oxygen molecules. They are responsible for scattering of blue color, and this is the topic of our lesson.